Hello! Today I'm going to talk about audio systems. So in previous videos we talked about some of the bits of audio systems. For example, we had a video on small signal amplifiers, we had another video on power amplifiers, and we had some other videos that relate to this, but now we're going to put everything together and just show how all this is put together into some audio systems. I'll be taking a bit of a retro look at it, but modern systems are pretty much the same thing. I'm just using pictures of old stuff because that's what's available. So start by looking at a complete amplifier system, and rather than redraw it on the board, I'll just put the schematic up here. So we start out with a microphone, which is an audio input. This audio input can come from many different sources. It could be a microphone, could be the tape head for an analog audio tape system, or from a video system, could be a digital to analog converter from an MP3 player or a CD player, or from a DVD player, whatever you might have. But we have a small audio signal, and what usually comes from this entity, whether it's a microphone or a DAC or a tape head, is a pretty weak signal and needs a lot of amplification. So we start out with a preamplifier, which in this circuit is just a simple small signal amplifier, which we've discussed earlier, so I won't go into any detail about the actual circuit, but we just have a single NPN transistor with the supporting components such as the input coupling capacitor and the output coupling capacitor, which couples it to the next stage. And I'll just make a quick mention about impedance matching. We talked about that way back in DC circuits, but this is where it becomes relevant. So we have to have an impedance match between the microphone and the input of the small signal amplifier. And so impedance matching means essentially if we have a low impedance microphone, we need a low impedance input. And if we have a high impedance microphone, we have to have a high impedance input. And if we don't match them, we will get problems such as a low impedance microphone going to a high impedance input may end up overdriving the input and give us distortion, harmonic distortion, some clipping. Or if we have a high impedance microphone going to a low impedance input, we won't be able to develop enough voltage at the input to really have anything to amplify. So we need to make sure that those impedances match. And in talking about PA systems, we talked about the importance of low impedance and high impedance microphones and making sure we have a match there. So I go into more detail in the video about public address systems. So then out of this small signal amplifier, single stage amplifier, we have a coupling capacitor to the next stage. Once again, we need to match the impedances, make sure that the output impedance matches the input impedance. The output impedance of this stage is essentially going to be the resistance of the collector resistor. And so if that's a 1K resistor, that's a fairly low impedance, and so we would have a low impedance input. And we may have to make some circuit decisions on that. But typically a bipolar junction transistor, as we have here, has a low impedance, so it's a good match. And this is our voltage amplifier. So first we had a preamp, then we have a voltage amplifier, and this is mainly to develop enough voltage to run the last stage, which is the power amplifier. So the power amplifier, I suppose you could call it a current amplifier because its job is to deliver enough current to the load to develop the power we expect to deliver. So this is probably an 8 ohm or 4 ohm or 16 ohm speaker, and we need to develop enough current to get the power we want, which may be, well, it depends on the speaker, might be maybe a total of 20 watts or so, but we need to get enough current into that speaker to develop that power, because power, of course, is your voltage times your current. Or in sometimes we have to look at the I squared R, the current squared times the resistance or the impedance. But we need to have enough current to make that speaker move. And so that's the job of the power amplifier, is to take that voltage, which we've just developed enough to drive that power amplifier, then that power amplifier can now deliver enough current. So this diagram here is a transformer coupled push-pull amplifier. So it picks up the input from the collector of the transistor of the voltage amplifier and then divides that into these two transistors, because one transistor amplifies one half of the cycle and the other transistor amplifies the other half of the cycle, finally driving the speaker. So real quickly in that push-pull amplifier, I just want to remind us that we have two transistors and they are coupled to a transformer which goes to the transistor over here. And so that's in the collector. That couples magnetically over to the power amplifier. And that goes to ground, of course. And I'm oversimplifying this, but not much. So there's our positive, or VCC there. And so we know that this transistor is going to amplify the positive half of the signal. So here's the signal coming in. Well, when we go negative, this transistor is going to be cut off, so this transistor kicks in. So the first half of the cycle is amplified by this transistor. The second half of the cycle is amplified by that one. So we have current flowing this way. Then we have current flowing that way. And of course, when the current is flowing this way, we get a magnetic field of one direction. So that magnetic field builds like this and then collapses. Then when the second one comes up, that magnetic field is reversed. So it builds this way and collapses that way. And that goes to the final stage, which then goes to the speaker. And out comes our sound. So that's a transformer coupled power amplifier, and I've talked about those in detail earlier. And just to remind us that they exist, we have the transformerless amplifier. The advantages and disadvantages are the transformer coupled amplifier needs heavy and bulky transformers, but it's a simpler circuit. But this transformerless circuit requires two power supplies, so that's a trade-off. But this is very common because it eliminates the transformer, and so the top transistor amplifies the top half of the signal, the bottom transistor amplifies the bottom half, and we have a current going back and forth through the speaker here. More details in my video on power amplifiers. I don't want to go into details on that now. So that is our basic system. We have a very tiny signal coming from some audio source, such as a microphone, from an analog tape head, a digital to analog converter, and in the case of a digital to analog converter, we might be able to bypass the preamp because they can have a fairly large output. But in a microphone and a tape head, we have a very weak signal which will require a preamplifier. And in the case of a phonographic pickup, there are multiple types of those, but the most popular are magnetic. And those magnetic pickups also have a very weak signal and require a preamplifier. One thing to note about a phonograph pickup is we have to deal with the equalization on the record. I'll talk about this in detail when I talk about phonograph players in a subsequent video. But to overcome the noise on the surface of the record, as we drag that needle across the record, of course, we get noise. And that noise is greater at higher frequencies than lower frequencies. So what they do is they boost the high frequencies on the record, and then when they play back, they boost the low frequencies to compensate. And so if I go directly from that magnetic pickup to a regular amplifier, it's going to sound very tinny because it's going to be very rich in high frequencies. So your preamplifier that's made for your phonograph input, which will be clearly labeled on your components, is going to have that equalization in there as well as being a preamplifier. If you have a ceramic cartridge in your turntable, which I think is incredibly rare, I don't even know if you can get those these days, but back in the day a lot of phonograph players had ceramic pickups, which are piezoelectric microphones basically attached to the needle, and they put out a pretty strong signal, so they didn't need such a preamplifier. So that's something you will see if you have a component setup, which I'll be describing in a moment. If we can imagine some feedback going from the output back to the input, that feedback would have a filter that gives us that equalization that we need. In fact, here's an actual circuit here. I don't know if you can see it very well, but this is the actual preamp from a realistic STA82 back from the 1970s. This is the preamp for the phono input, and you'll see that there is some feedback going from the second stage back to the first stage with some capacitors and resistors in there that gives it the filter curve needed for the RIAA equalization. RIAA is the Recording Industry Association of America, which set the standard that we use for vinyl record equalization to this day. Now, one thing we need to know, which is very important, is that we are amplifying a very weak signal, and so this is very susceptible to noise. If any noise gets in here, it's going to be amplified, and this will determine the inherent noise of the whole system. So we need to make sure that we only get the signal from the entity we are trying to record and not get any noise from the outside. So you'll usually see shielded cable used for microphones and tape heads or phono pickups so that we don't pick up any outside noise. And here's a picture of some simple shielded cable. It's not sophisticated like coaxial radio transmission cable where the tolerances are very tight. We just have a shield around a wire. The shield is the ground and the wire carries the signal. This is an unbalanced signal, but we might have two wires, maybe a twisted pair inside the shield, especially for long runs with microphones, so that we also have the inherent noise canceling of the twisted pair, which I talk about in other places. So we want to have shielded cable to eliminate noise going from the pickup to the preamplifier, because if we pick up any noise there, that noise gets amplified. So we need to make sure we have a very low noise system at that point. So now we'll just take a look at some finished systems. I'm not going to get deep into public address systems. I'll do that in another video, but public address systems are a little different from our home stereo systems. Two of the biggest differences are the types of microphones and the inputs used. Typically, a PA system will use a balanced microphone with a shield around two twisted pair of wires. And then we have to deal with either high impedance or low impedance microphones. With a home stereo system, we don't usually deal with microphones unless we have a recording unit. Our home stereos will not have a microphone input, but if we have a tape recorder or a CD recorder, if those are still a thing, we would have a microphone input for those, and that's dealt with inside that particular unit. And on the output of a PA system, we don't have an output that's designed for a particular speaker of a particular impedance, but typically public address systems, which are designed for many, many speakers, and we don't know how many they're going to be, they are what's called a constant voltage system. And so they have speakers where we have a transformer that connects the speaker to the voltage rating. So we have an 8 ohm speaker with a transformer attached to it, and there will be tap-offs for like a 70 volt system or 100 volt systems, and you tap that off and the amplifier will amplify to the same voltage regardless of the impedance out there on those speakers. Because as you know, if you put speakers in series, your impedance will go up. If you put them in parallel, your impedance goes down. So we have to deal with that. We have a bunch of speakers in parallel. We're going to have to increase the output to keep everything the same. And so that's what they work on, is working on a constant voltage to make sure that the output is the same whether we have 2 or 3 speakers or 10 or 50 speakers or whatever. But I go into that in detail in my video on public address systems. So we're just going to look at home entertainment systems real quickly right now. So here is a ad from a 1977 Radio Shack catalog. I'm using this because I like the old-timey stuff. I still have an old-timey receiver. In fact, I had a realistic STA-82 way back in the 70s, and I eventually sold that. And when I wanted a system, maybe I guess about 15 years ago, I started doing some research for a new stereo system to go with my home entertainment, and I didn't like the reviews I saw on anything, expensive or cheap or whatever, but I really liked that old STA-82. So I went on eBay and I bought one, and so I still have that 1970s STA-82, and the capacitors haven't gone dry yet because it still works very well, and that's my main amplifier. So here's an ad for a component system from Radio Shack in 1977. This is not the STA-82. I don't know which model this one is. I'll stick it up there for what it's worth. But we have here a phonograph player, a tape deck, a compact cassette deck. Ooh, fancy. I went for this particular year because the year before they didn't have a compact cassette deck, at least not one that looked like this. They had 8-track. Oh boy. Things have changed. And so we have the turntable, we have the tape deck, and the combination AM/FM receiver and amplifier. A lot of times people would buy a separate receiver. So you'd have a tape deck, a phonograph player, a receiver, and an amplifier all separately, but this is a combo set here, which is very common. Plus we have our speakers and microphones and headsets that all came in this system for a inexpensive $999 back in 1977. That would be about $5,000 today. Boy, have things changed. I forgot what I paid for my STA-82 back in those days. I know I bought it new. I did buy some 4-channel tape recorders. They were $300 each, which would be what, about that would be about $1,500 each today. The microphones cost me $30 each. That would be about $150 today. You can buy microphones for about $30 now. So the price of audio components have actually stayed about the same. They've been somewhat immune to inflation for one reason or another. So anyway, there's what a system was in those days. Here's the back of my STA82. So you can see the connections on there. As you can see, it's mostly RCA connectors except for the speakers. I have connectors for 4 speakers, front speakers and back speakers. But the front speakers and the back speakers were the same. It was not a 4-channel system. Everything else is an RCA connection. And then we have the antenna connection for the FM antenna, the AM antenna. We have a ground connection, which is for connecting to the phonograph. So there's a ground wire that comes from your phonograph. You have your 2 wires that come from the pickup, which go into your phonograph inputs, your left and your right, plus your ground wire comes in. You need to have a good solid ground between those, otherwise you'll pick up noise. The phonograph, as I mentioned, that goes through a preamp that's needed for the weak signal coming from the magnetic pickup, and it also has the RIAA equalization. Then we have a tape in and a tape out, and the reason for that is that a tape deck can both record and play back. So the tape in comes from the playback of the tape player, and the tape out would go to the record of the tape player. So I can tune into something on the FM radio, and I can send that to the tape out and go to the tape player and record that, and then play it back coming back from the tape in. And then we have the auxiliary, which we can plug whatever we want to in there. Of course, today I have a TV plugged in there, so my TV sound goes into the auxiliary. I don't have a tape deck on it right now, but I could. And so on the front of the unit, we have a selection knob that, off the top of my head, I'll put it up here and I'll try to remember what's on there. So I had the auxiliary input, the AM radio input, the FM radio input, then had FM muting, which simply means that it would only actually amplify if there's a signal coming in, so you didn't hear a bunch of hiss between stations on the FM. Then had the phono input, and for tape you had to press the tape monitor button, so it was a separate button there. So those are the connections on this particular unit, all RCA connectors, which have line level inputs and outputs, which means we expect a maximum of 1 volt RMS either going in or going out. Of course, it might be lower with a weaker signal or lower volume, but expects a maximum of 1 volt RMS. If you go above that 1 volt RMS, you're going to start clipping and have distortion. And just came to mind, I should have mentioned this earlier, but another possible input, which could be for your auxiliary, would be from a computer sound card. Computer sound cards typically today will have a microphone input and a line output. Some of them also have a line input. Some have a combination microphone line input. Now your sound card is going to always use phone plugs. And so here's different sizes of phone plugs. You have 1/4 inch, and you have the 3.5 millimeter, and we have stereo, mono, and 4 connector ones depending on the device. But your connections from a sound card are going to plug into a stereo 3.5 millimeter phone plug. That plugs in there, then you have to break it out into RCA connections to go into this. So you'd have to have an adapter cable of some sort. You can buy all sorts of cables with a phone plug on one end and RCA on the other, or whatever you need to connect a sound card to one of these, which is not an uncommon thing to do. And once again, that would have a line out and possibly a line in. Possibly the microphone in can double as a line in depending on a jumper. And a sound card may have a speaker output, but most likely it's going to be the line output that goes to your speakers. So that's how you integrate a computer into one of these systems very easily. Just your line out of your computer card goes to the auxiliary in. Or if you are going to record on your computer, you can have your tape out go to the line in of your computer card, and you can record whatever is coming through your stereo, whether it's your turntable or radio or tape or whatever. So if you want to digitize some old analog tape, you can run your tape machine into your amplifier, run the tape out to the line in of your sound card, and then use your software to make a digital recording. So those are the interconnections when you have a component system, but you can also get systems that are all in one. This one here looks like it might be a component system with the components stacked on top of each other. It'd be hard to tell them apart, except I know that this particular model of Sony system is actually one big box. You pick it up all in one, and all the connections are inside, with the exception of an auxiliary input and your speaker outputs. So your speakers are separate. So there's no way to monkey around with this. You can't get a signal out of it. You can put a signal in, an auxiliary in, but there's no signal out. So it's certainly not as versatile as a component system, where component systems can get quite elaborate, where multiple audio devices going in, and some of the receiver amplifiers accommodate that. And just real quickly, I do talk about multi-channel sound in another video. You could get in the day receivers that had a 4-channel sound system that could come from 4-channel tape recorders or 4-channel vinyl records. Yes, they made 4-channel vinyl records. I talk about it in the multi-channel sound video. So there we are, audio systems. We're going to have a sound producing device such as a microphone, magnetic cartridge, tape head, DAC output, whatever. It's going to go through a preamplifier, a voltage amplifier, and then a power amplifier, and finally go to the speakers. And then we discussed all of the interconnects that you might have. And if you have a component system, they're going to be some variation or additions to what I already talked about. So there we have audio systems. That's about all I need to say about that. So I hope you found it useful and informative, and hopefully when you get that retro audio system, you know how to set it up now. So if you did find this useful and informative, please give me a thumbs up. It really helps the channel. And if you want to study electronics technology for free, you can go to vocademy.net and sign up for my free course. And if you want to help me put these videos up and keep Vocademy free, you can go to patreon.com/Vocademy and pledge your support. Even those $1 a month pledges add up and make a big difference. And if you want to make a one-time donation, you can go to paypal.me/voced, VOCED. So again, thank you for your support, and thanks to everyone for watching.